Hello everyone, welcome to the Bharat Academy. I am Manoj Thaplyal and today's topic is again measure of dispersions. This is also called average of second order and measure of dispersions को हिंदी में विचलनशीलता के मान बोलते हैं. As we have already discussed the different type of measure of dispersions in our last lecture. Mainly there were four type of measure of dispersions. First is range, second is quartile deviation, third mean deviation, and fourth one is standard deviation. We discussed range and quartile in our last class, and today we will take mean deviation and standard deviation. As you know, student, the dispersion is defined as the extent to which the values differ from the central value. Range and quartiles are not useful in measuring how far the values are from the central values. The range and quartile deviation are totally based on the spread of the values, and the other two measures of dispersions, mean deviation and standard deviation, are totally based on the deviations of the value from their central value. Central value means mean, mod, median. Now today we will discuss mean deviation and standard deviation. Now the third measure of dispersion is mean deviation. Now the definition of mean deviation. The mean deviation is defined as the mean of the absolute deviation of the observations from the suitable average, which may be arithmetic mean, median, and mod. Since mod is not considered to be a stable average, hence generally we calculate mean deviation about either mean or median. Mean deviation MD for ungrouped data. Let x be any variable, any variate you can call, having n values x1, x2 up to xn. So then mean deviation is defined as MD x bar, mean deviation about mean. This is mean deviation about mean. It will be summation absolute value of x minus x bar upon n. अगर mean deviation about median होगा, this is mean deviation about median, so then it will be summation x minus m upon n. These two are absolute measures of dispersions, mean deviation about mean, mean deviation about median, and these two are relative measures of dispersions. If this is mean deviation about mean, the coefficient of mean deviation will be mean deviation about mean upon mean. If the mean deviation is found about median, the coefficient of mean deviation will be mean deviation about median upon median. वो डिपेंड करेगा कि किसके अबाउट कैलकुलेट कर रहे हो. ठीक है. So these are the formulae to be used to find the mean deviation for ungrouped data. Now we take an example based on ungrouped data. Now the example is calculate the mean deviation about mean for the following data of urea in milligram per dl present in the blood sample of 11 patients in hospital. Now the variate is urea. In this case, this is content of urea in milligram per deciliter is 15, 20, 17 up to 12, and number of observation here are 11 patient. Mean deviation about mean is summation x minus x bar upon n. X bar, you will have to calculate x bar first. X bar means arithmetic mean, summation x upon n. Add all these values 15, 20, 17 up to 12 divided by 11. So this is 165 by 11. The x bar is 165 by 11 equal to 15 mg per dl. So now form a table for the measure of dispersions, which is mean deviation. These are the values of x: 15, 20, 17, 19 up to 12, and their total is 165. But from the formula it's obvious that you have to find x minus x bar. X minus x bar means x bar is 15. Subtract this mean value from each value of x. 15 minus 15, this is 0. 20 minus 15, this is 5, and so on. And again, from formula you have to find the absolute value of the x minus x bar. The absolute value means all value will be positive. Absolute value of 0 is 0, absolute value of 5 is 5, absolute value of 2 is 2, absolute value of minus 2 will be plus 2, absolute value of minus 3 will be plus 3. Absolute means you have to convert all these values into positive. The total value of x minus x bar is 38. So from formula, mean deviation about mean will be summation x minus x bar upon n. Total value of x minus x bar's absolute value is 38. 38 upon 11, this is 3.45 mg per dl. This is mean deviation. Now relative measure of dispersion coefficient of MD is the mean deviation about mean upon mean. So this is 3.45 upon 15, this is 0.23. एब्सोल्यूट वैल्यूज़ का मतलब ये है कि जो भी तुम्हारी x माइनस एक्स बार मतलब डेविएशन, ऑल डेविएशंस, वो कुछ पॉजिटिव भी हो सकता है, कुछ क्या नेगेटिव भी हो सकता है, लेकिन एब्सोल्यूट वैल्यू का मतलब क्या होगा? पॉजिटिव वैल्यू. क्या मतलब है इसका? पॉजिटिव वैल्यू. तो पॉजिटिव वैल्यू सब नेगेटिव जो भी डेविएशंस है उनको पॉजिटिव में बना करके टोटल वैल्यू निकालो x माइनस एक्स बार का एब्सोल्यूट वैल्यू का टोटल. दिस इज 38. और तो मीन डेविएशन मीन के अबाउट, अर्थमेटिक मीन के अबाउट मीन डेविएशन निकालने का सूत्र है समेशन एब्सोल्यूट वैल्यू ऑफ x माइनस एक्स बार अपॉन n, 38 अपॉन 11. दिस इज 3.45. और जो रिलेटिव मेजर ऑफ डिस्पर्शन है कोफिशिएंट ऑफ MD, अगर तुमने मीन के अबाउट निकाला है तो मीन डेविएशन अबाउट मीन अपॉन मीन होगा 3.45. मीन की वैल्यू 15 थी, तो 3.45 अपॉन 15 0.23. दिस इज all about the mean deviation when the data are in individual series or data are ungrouped data. Now we calculate mean deviation for group data. Group data means the variables and their corresponding frequencies are given. X is the variable having these values x1, x2 up to xn, and their corresponding frequencies are f1, f2 up to fn. In this case, the mean deviation about mean MD about x bar will be summation f into absolute value of x minus x bar upon capital N. Here this capital N is the total frequency, total number of frequency you can call it, or x bar is arithmetic mean. You can calculate it from different methods, summation fx upon n, or for step deviation method, and for shortcut method you can calculate x bar. So this is mean deviation about mean, and the mean deviation about median will be MD about median will be summation f absolute value of x minus m upon n, where this m is your median. And similarly we can calculate coefficient of MD about mean, coefficient of MD about median. Now the question based on discrete data is calculate mean deviation about mean for the following triglyceride present in the blood sample of 50 patients in pathology lab on a certain day. Triglyceride x mg per dl are given 5, 15, 25 up to 65. Number of patients means frequency are given 8, 12, 10 up to 7, and total number of frequency summation f is 50. This is your capital N here. Now I am trying to calculate the arithmetic mean by step deviation method. You can apply this method when the differences between consecutive two values of x are same. Here consecutive difference between two consecutive value is 10. 15 minus 5 10, 35 minus 25 10. If this is same, then you can apply step deviation method. It will consume less time. The x bar is a plus summation fu upon n into h. These are the values of x. Triglyceride, these are the value of f. D is the deviation about assumed mean. Assumed mean you can calculate from the value of x. Whatever value is in the middle, whatever value of x is in middle, you can take it. Assumed mean a. Here I have taken a equal to 35. The d is x minus a. Subtract this 35 from each value of x. 5 minus 35 minus 30. 15 minus 35 minus 20, 25 minus 35 minus 10, and similarly 65 minus 35, this is your 30. This is d, but actually in formula you need u. What is u? U is d upon h. Deviation upon h means difference between two consecutive numbers of x. Here the difference is h. I have taken t upon 10. H is 10 there. The minus 30 upon 10 minus 3 minus 20 upon 10 minus 2, similarly up to 30 upon 10, this is 3, this is u. Now in formula you need f into u, these are the frequencies. U is this, multiply this number, 8 into minus 3, this is minus 24, 12 into minus 2 minus 24, and similarly 7 into 3 is 21. These are the values of fu. Now put all these values here, you will get arithmetic mean. X bar is equal to a plus summation fu upon n into h. A is 35, fu is minus 30 upon n is 50 total frequency into 10. So this is x bar is 35 minus 6 is 29. This is arithmetic mean. Now from mean deviation formula you need summation f into x minus x bar. X minus x bar, its absolute value. Absolute value means positive value. So here this is x bar is minus, x bar is 29. The 5 minus 29, this is actually minus 24 but if you are trying to calculate absolute value, so this will be positive 24. Similarly, calculate all these absolute values. Absolute value means positive value. So these are 24, 14 up to 36. Now you need f into absolute value of x minus x bar. This is f. 8 into 24 192, 12 into 14 168, similarly up to 7 into 36 is 252. The total value of summation f into x minus x bar is 800. Now mean deviation about mean is 800 upon 50, this is 16 mg per dl, and its relative measure of dispersion coefficient of md will be md upon mean, 16 upon 29, this is 0.56. Now the question based on mean deviation for continuous distribution is, question is calculate mean deviation about median for following data. Data is marks are given. This is class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and number of students who secured these marks. These are frequencies 6, 8, 7, 6, 5. Total frequency are 32. This is actually your capital N total frequency. We have to find mean deviation about median. So for median you have to find cumulative frequency. First cumulative frequency will be the same as the frequency. Keep on adding 6 plus 8 14, 14 plus 7 21, and last is 32. These are the cumulative frequency. Now in formula you need x. What is x in continuous data? X is always mid value of the class interval. 0 plus 10 by 2, this is 10 upon 2, this is 5. 10 plus 20 by 2, 30 upon 2, this is 15. Like this you can calculate all mid values. These are the value of x. Now we have to calculate median first, x minus m. Here m is the median. To calculate median you have to check n by 2. N is 32. N by 2, 32 upon 2, 16. This n by 2, 32 by 2 is 16, which lies under cumulative frequency 21. for which the class interval is 20 to 30. Here this L is the lower limit of the median class. This is actually your median class. Lower limit is 20, H gap between the class interval, this is 10, frequency is 7, and C is the cumulative just above it, this is 14. The median M will be L plus N by 2 minus C upon F into H. L is the lower limit, this is 20, N 32 upon 2, C is minus 14 upon 7 into 10. This M is 20 plus 20 upon 7, this is 20 plus 2.85, this is actually your median 22.85. We have to find the absolute value of x minus m. M is the median. Median is 22.85. Actually, x minus 22.85. X here is 5. 5 minus 22.85. Actually, this is minus 17.85. But this is, you have to find the absolute value, means put it as positive value 17.85. Similarly, you can calculate all absolute values of x minus m. Now, for the continuous data, you have to find f into absolute value of x minus m. F is the 6, absolute value of 17.85, this is 107.1. F is again 8 into absolute value 7.85, 62.8. Similarly, you can calculate all these values of f into absolute value of x minus m, and their total is 368.6. So now the mean deviation about the median will be summation f into absolute value of x minus m upon n. Absolute value of summation of absolute value of x minus m is 368.6 upon n. N is 32, which is 11.52. Now the relative measure of dispersion's coefficient of MD will be mean deviation about median. Mean deviation is 11.52 upon median 22.85. This is 0.504. This is the relative measure of mean deviation about median. Now the last measure of dispersions, which is very important one, is the standard deviation. What is standard deviation? Standard deviation is the measure which shows how much variations from the mean exist. It is a proper measure of dispersions or variability because it returns to the original unit of measure of data set, and small sd means high degree of uniformity of the observations or homogeneity of the series. And the definition of standard deviation is the positive square root of the mean of the squared deviation from the mean. From the mean means arithmetic mean. This standard deviation is also known as root mean square of the deviation, and the formula for the SD, its definition itself is a formula. SD equal to square root of squared deviation, means summation I varies from 1 to n, xi minus x bar its whole square upon n. This is square root of the mean of the squared deviation. This is SD. X bar is arithmetic mean, or n is number of observations. Now there is another term, variance. What is variance? Variance is the measure of how notably collection of data is spread out. वेरिएंस होता है ये चेक करने के लिए कि डाटा जो है कितने फैले हुए हैं. इफ़ ऑल द डाटा वैल्यूज आर आइडेंटिकल, अगर सारे डाटा वैल्यूज़ की वैल्यू अगर सेम है तो दैट इंडिकेट्स दैट द वेरिएंस इज जीरो. अगर सारी वैल्यू सेम होगी तो वेरिएंस क्या होगा? जीरो. ए लिटिल वेरिएंस, अगर वेरिएंस कम है, ए लिटिल वेरिएंस रिप्रेजेंट्स द डाटा पॉइंट्स आर क्लोज टू द मीन और ईच अदर. अगर वेरिएंस की वैल्यू कम है तो इसका मतलब ये है कि डाटा पॉइंट जो है मीन के बहुत क्लोज हैं या आपस में भी बहुत क्लोज हैं. However, if the data points are highly spread out from mean or from each other, it indicates the high variance. मतलब अगर डाटा पॉइंट्स में अगर हमारी इस वेरिएंस की वैल्यू बहुत ज़्यादा है तो इसका मतलब ये है कि डाटा पॉइंट्स जो है मीन के चारों तरफ ज़्यादा फैले हुए हैं और आपस में भी एक दूसरे में बहुत उनमें फैलाव है. Now the definition of variance is, the variance is square of the standard deviation. जो भी तुम्हारे standard deviation की वैल्यू आएगी उसको स्क्वायर कर दो तो you will get variance. If standard deviation is denoted by sigma, तो variance will be sigma square. That is, if sigma is equal to square root of the mean of the squared of the deviations. I varies from 1 to n, xi minus x bar its whole square upon n. So where this is your standard deviation, this is SD, and variance will be sigma square equal to summation I varies from 1 to n xi minus x bar its whole square upon n. This is n upon n if n is less than 30. अगर 30 n की वैल्यू 30 से कम है तो स्टैंडर्ड डेविएशन में अंडर रूट ऑफ समेशन आई वेरीज फ्रॉम 1 to n एक्स आई माइनस एक्स बार का होल स्क्वायर अपॉन n लेते हैं. इफ़ n इज़ ग्रेटर देन 30 तो देन इट विल बिकम n माइनस 1. और वेरिएंस क्या होता है? स्टैंडर्ड डेविएशन का स्क्वायर है. So this is your variance. Now the variance you can calculate by another formula. As you know, variance, now this is sigma square summation I varies from 1 to n xi minus x bar its whole square upon n. Apply the formula of a minus b whole square. It will xi square minus 2xi x bar plus x bar its whole square. We have to separate all these values. This is summation I varies from 1 to n summation xi square upon n. 2x bar is purely a constant, you can take it out. It will become summation I varies from 1 to n xi upon n plus x bar is purely constant, you can write it summation I varies from 1 to n 1 upon n. And you know x bar mean is summation I varies from 1 to n xi upon n. This is mean, and summation I varies from 1 to n to 1 means n values. Put this formula over here. This will be summation I varies from 1 to n xi square upon n minus 2x bar, this is again x bar, x summation xi upon n. X bar summation I varies from 1 to n, 1 means this is n upon n, this is cancelled. So this is summation xi is whole square upon n minus 2x bar square plus x bar square. So this will be minus x bar square. So overall variance you can calculate from this formula. So variance sigma square equal to summation I varies from 1 to n summation xi square upon n minus x bar its whole square. Now the standard deviation is square root of the variance, you can call it. It is another definition of SD. Square root of variance is called SD. SD will be sigma equal to under root of summation I varies from 1 to n xi square upon n minus x bar its whole square. X bar is the arithmetic mean. There are certain properties regarding mean and variances. If each observation is multiplied by any constant, then the mean of the resulting observations become k times, and the mean of the resulting observations become k time the original mean, and the variance of the resulting observations will also become k time of the original variance. This is the first property. Second property, if each observation is added or subtracted by some constant k, then the mean of the resulting observations is also added and subtracted by that same constant k, and the variance of the resulting observations remains the same. It is not affected by the constant k. Now we start standard deviation for ungrouped data or individual series, you can call it. Let this x be any variate having these values x1 x2 up to xn. These are called observations. The number of observations are n. So then standard deviation sigma equal to under root of summation I varies from 1 to n xi minus x bar its whole square upon n, where this x bar is arithmetic mean. You can calculate it from different methods: direct method, shortcut method, or step deviation method. X bar summation x upon n, and this n is number of observations. This is when n is less than 30. N is number of observations I have mentioned over here. If n is greater than 30, then standard deviation sigma can be calculated by summation I varies from 1 to n xi minus x bar its whole square upon n minus 1. Now this is SD, and variance will be variance. What is variance? Square of the SD, sigma square. Next is coefficient of SD. Coefficient of SD, we can calculate SD upon mean sigma upon x bar. Now example based on ungroup data in case of SD is, question is find the mean respiration rate per minute and its standard deviation when 4 cases the rate was found to be 16, 13, 17 and 22. These are the respiratory rate. I have taken it as x. These are 16, 13, 17, 22 and its total is 68. The first I will find mean, arithmetic mean, summation x upon n means 1, 2, 3, 4 and number of observations are 4. This mean will be summation x upon n, 68 upon 4, this is 17. 17 is x bar. So from the formula it's quite obvious that you have to find x minus x bar, yani x minus x bar 17. So this is 16 minus 17, this is minus 1, 13 minus 17 is minus 4, 17 minus 17 0, 22 minus 17 5. The next column will be for x minus x bar its whole square. Minus 1 its whole square is 1, minus 4 its whole square is 16, 0 is square is 0 and square of 5 is 25. We have added all these, summation x minus x bar its whole square is 42. So now standard deviation you can calculate from this formula, under root summation x minus x bar its whole square upon n. So summation x minus x bar its whole square, this is 42 upon n is 4, this is 10.5, its under root is 3.2. This is your standard deviation. Variance is square of the SD, its definition of variance as well, square of the SD, this is root 10.5, its whole square is again same 10.5 and coefficient of SD is sigma standard deviation upon mean, 3.2 upon mean is 17, this is 0.188. The standard deviation for group data means when variables and their corresponding frequencies are given. Value of x are x1, x2, xn and their corresponding frequencies are f1, f2 up to fn. Here first of all you have to find capital N. Capital N here will be total frequency. Standard deviation sigma will be under root of summation f x minus x bar its whole square upon n, and variance will be square of the SD, sigma square. Coefficient of SD will be sigma upon x bar. X bar is the arithmetic mean of the given data. Arithmetic mean you can calculate from the various method. This is direct method. This is standard deviation method, and similarly standard deviation you can calculate from the various method. This is the direct method, this is standard deviation by standard deviation by step deviation method. In this case sigma will be under root of summation fu square upon n minus summation fu upon n its whole square into h. U is d upon s. D is the deviation, x minus a is the assumed mean, or h is the difference between the values or class interval. This is by step deviation method, this is standard deviation by assumed mean method. You can calculate SD by this method as well. SD equal to sigma summation fd square upon n summation fd upon n its whole square. Here d is again deviation, x minus a is the assumed mean, or n is total frequency. Now the standard deviation for the discrete series. The question is the daily high blood pressure of patient on 100 days are given below. These are the blood pressure mmHg. I have taken it as x, and number of days I have taken it as f. BP 102, 106 up to 126. Number of days 3, 9 up to 1. Now the total frequency is 100 and total frequency summation f is 100. I have to find D. D means deviation. Deviation from assumed mean. Assumed mean A is calculated by the values of x. Whatever value in the middle of x, you have to take it assumed mean. I have taken 114 as an assumed mean. D means deviation, x minus A, x minus 114, 102 minus 114, this is minus 12, 106 minus 114, this is minus 8, and 126 up to 126 minus 114, this is 12. Now you next column you have to find u is d upon h. D is the deviation, h means consecutive difference between the two number. Here x 102 106, the gap difference is 4, 110 and 106 4. If the difference between the two consecutive numbers are same, then you can calculate the arithmetic mean or the standard deviation by step deviation method. But if the difference between the two consecutive number are not same, then you have to apply formula for SD and arithmetic mean. You can apply the direct method. Okay, but here the difference between two consecutive numbers are same, so you can calculate it by step deviation method. So now u is d upon h, d upon 4 minus 12 upon 4 minus 3 minus 8 upon 4 minus 2, and like this 12 upon 4 is 3. Now in formula, standard deviation sigma is fu square upon n minus summation fu its whole square upon n its root into h. It means you have to find fu and fu square. U is d upon h, we have already calculated. F into u, f this number of days, and you have to multiply fu 3 into minus 3 minus 9, 9 into minus 2 minus 18. Similarly you can calculate all the values of fu, and total value of fu is minus 12. Now you have to find u square. U is minus 3, so u square is 9. U is minus 2, so u square is 4. Up to u is 3, so u square is 9. So last column will be for fu square. F is 3, u square is 9, fu square is 27. Up to 1 into u square is 9, this is 9. Add all these values of fu square, the total value of fu square you will get 154. Now find x bar by step deviation method. Step deviation method. This is a plus sigma fu upon n into h. A is, I have taken 114. Fu is minus 12 upon 100 into 4. 114 minus 0.48. The x bar arithmetic mean is 113.52. Now the standard deviation, under root of summation fu square upon n, summation fu its whole square upon n into h. Put all these values of fu square at n. Sigma you can calculate under root of 154 upon 100 minus 12 upon 100 its whole square. This is under root of 1.54 minus 0.01144 into h. So ultimately you get sigma equal to 1.23 into 4, which is sigma standard deviation is 4.94 mmHg. This is your standard deviation. Variance is square of the SD, you can calculate it. This is 24.50, and coefficient of SD, relative measure of dispersion, is SD upon mean. Sigma upon x bar 4.94 upon 113.52. This is your coefficient of SD. The standard deviation for continuous data. The question is find the SD for the following data. These are age in years, these are class interval 0 to 10, 10 to 20, up to 60 to 70, and number of patients means frequency 6, 14 up to 8. Total frequency that is 50. This is your capital N. Now x, what is x in continuous data? Mid value of class 0 to 10, 0 plus 10 by 2, this is 5. 10 to 20, 10 plus 20 divided by 2, this is 15. Like this you can calculate x, mid value of each class, up to 65. Now d is the deviation, x minus a is the assumed mean, which you have to calculate from the x, mid value of x. Whatever value is in middle, that will be your assumed mean. Here this 35 is in middle, that this you can take it 35a assumed mean. The d is the x minus a, x minus 35. This is 5 minus 35 minus 30, 15 minus 35 minus 20, and like this 65 minus 35, this is 30. And u is the d upon h, d deviation upon h. H means difference between class 0 to 10, 10 to 20, 20 to 30. This is h means 10. Minus 30 upon 10 minus 3 minus 20 upon 10 minus 2 up to 30 upon 10. ये again तुम्हारा 3 आ गया। नाउ यू स्क्वायर आप लोगों को कैलकुलेट करना है, यू -3 इसका होल स्क्वायर 9, -2 इसका होल स्क्वायर 4, सिमिलरली अप टू 3 इट्स होल स्क्वायर 9। तो नाउ ये फार्मूला आपका शो कर रहा है, स्टेप डेविएशन मेथड है, अंडर रूट ऑफ समेशन एफ यू स्क्वायर अपॉन एन और समेशन एफ यू अपॉन एन का होल स्क्वायर। एफ यू स्क्वायर का टोटल हो गया, टोटल ऑफ एफ यू स्क्वायर 205 एंड टोटल ऑफ एफ यू इज -25। यू पुट ऑल दीज वैल्यूज ओवर हियर, ये वैल्यूज यहाँ रखोगे तो एफ यू स्क्वायर 205 अपॉन एन 50 माइनस समेशन एफ यू -25 इसका 25 अपॉन 50 इट्स होल स्क्वायर into 10. So this is 4.1 minus 0.25 into 10. This is under root of 3.85 into 10 and sigma is 1.962 into 10. Sigma means standard deviation is data का, continuous data का. This is 19.62 और variance again variance sigma square 19.62 its whole square is 384.94 और इसी के साथ ही with this standard deviation for continuous data is over, इसी के साथ ख़त्म हो गए। There are certain properties regarding standard deviation. First is empirical relation. There exists an empirical relation between standard deviation, mean deviation, quartile deviation and standard deviation. If sigma is standard deviation, the mean deviation is equal to 4/5 times of standard deviation sigma. Quartile deviation is 2/3 times of standard deviation sigma, and quartile deviation is 5/6 times of mean deviation. So from these relation we find that 4 times of SD equal to 5 times of MD equal to 6 times of QD. This is the relation among these SD, MD and QD. And the next is limits of variability. The standard deviation shows the limit of variability by which the individual items in a distribution vary from the mean. For symmetrical distribution or normal distribution with mean, x bar is the mean and sigma is the standard deviation. Following area relationship holds. From x minus sigma to x plus sigma, it covers 68.27% of item, and from x minus 2 sigma to x plus 2 sigma, it covers 95.45% of item, or from x minus 3 sigma to x plus 3 sigma, it covers 99.45% of items. Now the coefficient of variance. What is coefficient of variance? This is a relative measure of dispersions and it is given by this formula. Coefficient of variance CV equal to sigma upon x bar into 100. Sigma is standard deviation, x bar is mean. The CB has a great practical significance and this is the best measure of comparing the variability between the series or between the groups, different groups. And the series and group for which the CB is greater is said to be more variable or less consistent, and on the other hand the series for which the CB is less is said to be less variable. It means that series is going to be more consistent and you can use in share market as well. For example, the coefficient of variance can be used for comparing the relative consistency of prices in the share market of 2 or more companies. It will help the investor in selecting the the prices for which they are relatively more stable. Thus the share which are more consistent in fluctuation will be preferred by the investors. Now the example based on the coefficient of variance is, in a series of adults the mean blood pressure was found to be 135 mmHg with standard deviation 10 mmHg. In the same series the mean height was 170 centimeter with standard deviation 6 centimeter. To find which character shows greater variation. Now the coefficient of variance for blood pressure is SD upon mean into 100. Here standard deviation is 10 and the mean is 135, and 10 upon 135 into 100 7.40%. This is coefficient of variance for blood pressure. Now the coefficient of variance for the height is SD upon mean into 100. Here SD is 6, mean is 170. 6 upon 170 into 100, this is 3.52%. It's quite obvious. CV of blood pressure is more than CV of height. It means the blood pressure is more variable character between these two. And the student, with this the topic is over. Now the student, if you have found this video interesting and helpful, please like this video and subscribe my channel. Keep watching these videos. I will be back very soon.